You're listening to The Samuel Angler, and my daddy is the host.
All right. Special thanks to my sweetheart for the introduction. If you're new here, my name is Rick Crawford, and I am the host of the Sustainable Angler podcast, president of Emerger Strategies, and founder of the Fly Fishing Climate Alliance. So, have you noticed that there are less insects stuck to your windshield these days? Well, you're not alone. And in fact, insects are in decline. But there really hasn't been a ton of research and science behind some of the prolific aquatic bugs that trout and trout anglers love. Enter the Salmonfly project. In this episode, we hear from Jackson Birrell and James Frakes, co-founders of the conservation nonprofit, the Salmonfly Project, whose mission is to conserve aquatic insects for future generations through research, monitoring, education, and sound management and restoration practices. Also, be sure to check out our website, www.thesustainableangler.com, to read blog posts, get caught up on previous episodes, and show your support of the Sustainable Angler podcast. The Sustainable Angler is a proud 1% for the Planet member and is available anywhere you listen to podcasts, and also airing Saturdays at 2 p.m. on Charleston's first and only community-supported radio station, Ohm Radio, 96.3 FM. The Sustainable Angler podcast is brought to you by Emerger Strategies and A New Earth Project, the sustainability initiative of Atlantic Packaging. Fly fishing taught me that learning to read a river for trout isn't just about finding fish. It's about understanding an entire ecosystem. At Emerger Strategies, we see this as a perfect metaphor for systems thinking. Each element of the river, from water quality and habitat to the aquatic insects that transform from emergers to adult mayflies, plays a crucial role. And we understand that businesses also play a critical role in the health of the planet. Measuring and improving your company's sustainability performance is the same as protecting your home waters. And responsible business practices ensure that our rivers remain clean, habitats are preserved, and biodiversity thrives for generations to come. Because when you protect what you love, you're not just protecting the planet, you're building a brand that stands for something. At Emerger Strategies, we help your business apply this holistic approach. By integrating sustainability, you not only conserve natural resources, but also create a thriving ecosystem for your business and the planet that you love. Visit our website at emergerstrategies.com to learn more, and let's protect what we love together.
We set out with the New Earth Project to really start a movement.
It's a global coalition of people who are deeply concerned and want to accelerate the transition away from problematic packaging to more sustainable solutions.
Our entire value proposition was built on helping companies package things better. We were doing sustainability before sustainability was cool. We just called it packaging optimization. And packaging optimization really is about using less. And we built our whole business on that. You know, people send us their products, their goods, and we help them design packaging systems and solutions for the least possible cost, utilizing the least amount of material. Use less is always the right answer.
And that's what I see with companies like a New Earth Project is it's like, we're just trying to create solutions for big companies and small, that makes it easier for them, cheaper for them, whatever it is, and then has less impact. Not just trying to tell people you should have less impact and making the choice forced on them. Like, make it better for everybody, and it'll make it better for the whole world.
We see the problem, and we are with you.
All right, thanks, Rick. This is James talking. My name is James Frakes. I'm one of the co-founders of the Salmonfly Project. We're a relatively new conservation organization. Um, Jackson and I got started because we were grad students actually in the same laboratory, and through working with each other, we decided, hey, let's start something together. I moved out to Missoula, Montana in 2016, and I moved here primarily because I was excited to fish. That's what brought me here. And then I fell in love with entomology at the University of Montana, and I've been working on that kind of thing ever since. So, Jackson?
And then, so James actually did his undergrad and his master's at the University of Montana. I came here to Missoula just for my PhD. I'd done a lot of entomology elsewhere, and that's kind of where my background is. I do fly fish, but most of my love of insects, my love of insects comes directly just from I love bugs, and I have for a long time. I got into hardcore entomology in my undergrad, did a bunch of research, published a bunch of papers, and it's been just a whole lot of fun since. So when I came to the university for my PhD, James was in the lab and we were thinking about similar scientific questions, started collaborating on research, and it was just like a great match working together. But as far as the founding of the organization goes, it was super serendipitous. Where one day I was in a meeting with a bunch of folks at the university. They were trying to figure out how to get more donors, and we started. I happened to be in the meeting as kind of the representative of the grad school students, and started talking about our work and our interest. And they were like, talking about ways that we could get funding to do stream work, and they got super excited. And the whole conversation actually steered away from how the university could get money to just like chatting about, oh, how can you fund angler focused bug research for conservation. I came back to lab and I told James, we got to start a nonprofit because all these people gave me so many ideas, and we got to run with this thing. But our mission is to conserve aquatic insects, really focusing on these stream insects, these fishable hatches. And we do that by filling in information gaps about the status and trends of aquatic insects, drivers of declines, their conservation needs. And we do that by setting up monitoring programs. We perform research. We have education programs. And then once we have more information about the bugs, then we work with restoration practitioners, conservationists, government managers to implement our findings and those of others into real world solutions. So right now, when people talk about declining hatches, conservation problems with bugs, not much is done. And we can talk about this later, if you want, dive into it more. But not much is done, mostly because there's just not enough data. Like, you can talk to the government agency folks, they usually are aware, but they just don't have the right data and the right locations to do anything whatsoever. So we felt like there was a giant gap there that we could, come in and hopefully fill that.
Well, from a non-data perspective, I mean, this is anecdotal, right? But I mean, and I'm sure it was in decline when I was seeing it, but and I've heard this from friends that I have that live out west still. It was like I don't know if it was a few years ago, but 10 years ago there were more insects on your windshield than there are today. When you're driving around, like that's an anecdotal but observation, but I feel like those are also things that like anglers bring to the table in terms of like understanding. Or it's like here in Charleston, okay, we fish for redfish, and we have what's called flood tides and full moons and new moons, and so there's a tide chart, and despite the tide chart saying what it is, again, observational, I'm not out there measuring the tide or anything, but the tides are higher than what the tide chart is calling for. So it's like, all right, well, this is sea level rise. Like, that's anecdotal. So like, I just feel like it's interesting that, I've heard this from other anglers who are like, yeah, I'm just not seeing as many bugs in my windshield. But let's talk about some of, like, you just mentioned, like, this lack of data. Like, what is it with aquatic insects that there's maybe people sort of noticed this, but there wasn't enough data or science behind it.
Yeah, that's totally the anecdotal evidence of that. Seeing less insects on your windshield is one we hear pretty often. And globally, people are calling it the insect apocalypse right now, right? And that's, terrestrial and aquatic insects are in decline across the globe. And so, yeah, that's totally true. It's anecdotal to say that there's less insects, but there is a pretty good body of work to back up those claims, saying that insects are definitely in a rough spot right now, everywhere.
And what we have are a number of case studies, really. And it's the scientific case studies that give, I say, validity to the anecdotal observations. So, one of the main ones that people cite and that brought awareness to this issue, I would say globally and among just regular folks, was this study in Germany. And there was this program there for 30 some odd years where they were 27 years where they were monitoring the amount of flying insects across all of their protected lands. So that's equivalent to our wilderness areas, national forests, state lands, etc. And they found just since the early 90s a over a 70, I want to say 70 or 75% decline in aquatic insects over about a 30-year period.
Wow.
It's completely mind-blowing. And that's within protected land. That's not like ag land. That's within protected land. And that really got a lot of attention. And there's been a number of studies since then, actually some using the windshield technique, that there are some European researchers that actually have used that. Not just anecdotally, but for legitimate research. And I've even, read about, people strapping bug nets to their cars and having people drive known loops at different, over different years, and the amount of insects that go into that net, and they measure the biomass. So all of that is verified, at least in parts of the world. But what we do lack, if we're going to conserve, let's say, green drakes, for example, Western green drakes or salmonflies, the namesake of our organization, or Hendrickson's, what you need is like temporal data on that bug in certain spots, right? Because if you're going to have like the state of North Carolina doing something about it, they need data on the North Carolina bugs, on your rivers, or if, so, and that's really the data that is lacking, is really specific. The buzzwords we use are status, trends, and drivers. And even if we know there's a broad problem based on these case studies, if there's not that really fine scale information, specific species, specific locations, what's causing it, not much can be done.
All right. So, interesting. So I guess in general, without getting, insect apocalypse globally, I guess you could argue, it's like you see the same thing with biodiversity in general, right? There has to be like this declining trend that has to do with a multitude of reasons, but generally with aquatic insects, which is kind of what we're talking about today, what is the trend, and the trend is that they're declining, but what is the drivers that we think are responsible for that?
Sure. Yeah. I mean, just to take a step back, it's important to note that aquatic insects in general are way understudied compared to other groups of organisms, right? Like there's a lot more data on terrestrial insects.
And if I can step in here, never mind compared to, fish or charismatic vertebrates. I mean,
any mammal.
Yeah, exactly. Yeah.
So, yeah, there's a huge lack of knowledge in that department. And what we're basing a lot of our efforts on is to fill that gap. And we're also relying heavily on the angling community, right? We have a lot of whistleblowers who are these seasoned veterans who've been out there on the river monitoring these hatches, whether they know it or not. They're realizing that their favorite hatches are declining in certain areas. And we try to collect that information and verify it. That's one of the best ways that we can add some validity to those claims by the anglers.
Interesting. And in terms of that, it's like you got an angler who's anecdotally saying, and they're able to then contact Salmonfly Project, and they're like, "Hey, man, like we used to get the Salmonfly hatch, in this 2 or 3 week period every year, I'm seeing less of them, or it seems to have shifted. Is that sort of how that process works?
Yeah, exactly. People can reach out to us on our on our emails, but we even have these nice little forms. They're called stakeholder questionnaires on our website, where we have questions targeted towards anglers that say, where have you been fishing? Where have you been observing bugs? What have you noticed over the last few years or over your lifetime? Um, what's been going on? Why do you think it's occurring? Positive trend, negative trend, what species? We try and ask all these questions to provide, like James says, informed anglers the opportunity to give what data they have, whether it's anecdotal or not. And that's really important because there's not that many scientists doing it. We're just two individuals. We can't be everywhere. And even if we can't publish the data on their observations, it really guides where our focus is. And, if there's some guy out there that's been monitoring whatever hash for 50 years, he says it's gone, it's probably gone. Usually when they're out there paying attention that much and that into fly fishing, they're pretty good naturalists, entomologists.
Yeah.
So yeah, it's really important.
Yeah, and I think you would, especially as fly anglers, right? I mean, that was when I first got into fly fishing, that was what really sort of grabbed my attention, was entomology. Just like when you start to understand the life cycle of a bug, that's also like that's a crash course in systems thinking, right? Which is a term we use a lot in sustainability for businesses. Like you are part of a system that's part of a system, and you're within this system. So it's like the river and the bigger system, and ultimately the planet, right? And so I think it's cool that you've got these anglers who just by nature are very observant of the aquatic insects and what they're doing, and you're able to actually put some of that to use and put some science behind it. So the what I guess from the surveys that y'all have done, or the responses y'all have gotten from anglers, what are some of the findings from that? Or maybe, I don't know how to phrase it. What's the best way? Either what are some of the findings, or what are some of the most common responses that you get that y'all are then able to validate with science?
Good question. And I would say, first of all, like the observations we get from anglers better steers the locations of our research and the focus of our research more than, telling us exactly what happens. It gives us like, oh, we need to go look at that.
Yeah.
It really acts as that kind of guide. But as far as our research, what has our research shown? It kind of goes back to that previous question about drivers that you asked that we haven't fully answered, is that unfortunately it's complicated.
Right.
And it might be obvious when you say it, but a lot of the time, people will say, "Oh, what's driving it? Oh, it's climate change, or it's dewatering, or it's X, Y, or Z." But more often than not, what the data shows, it's a combination of everything, kind of a death by a thousand cuts. And we can talk about this more if you want, but I mean, climate change is really important to think about. Don't get me wrong, like climate change is a big deal, but as far as water goes, it's hard to change the temperature of water. And for aquatic systems, they've been kind of buffered against some of the temperature change, and it hasn't warmed as drastically as on land. So the problems that we see with bugs probably aren't very much climate related. I think at least temperature related. They're probably related to a bunch of other stressors that have been compounding over decades. We're talking ag, we're talking water extraction, various kinds of pollutants that remove oxygen from the water, sedimentation, also, and the list goes on and on and on. Heavy metals, and that's really the focus of our master's and PhD work, was on how complex interactions among factors can influence the performance and survival of bugs, really mostly on stoneflies.
Yeah.
So I would say it's complicated, and that's why we need so much effort into this. We can't just say, oh, it's this everywhere, and the drivers are going to be different from river to river, from region to region, from continent to continent. So,
Yeah, I mean, for example, like it'd be nice to be able to say, yeah, the Earth is warming on average, right, in the summertime, but that is not the direct single factor that is causing the declines that we're seeing, and it's it is anthropogenic issues that are causing the declines, but it's a combination of all these different factors. You've got reduced flows from water withdrawals. That in combination with warmer temperatures creates like extreme stress because you have hot river temperatures mixed with periods of low flow, which kind of exacerbates the issue.
Uh-huh.
And then on top of that, you have increased nutrient loading and pesticides being added to the water.
Well, right. I was going to ask about that because it's like it seems like there are some. I mean, and you have to pardon my ignorance, but it's like you see it in Florida, right, with algal blooms, like pesticides, fertilizers, like all this. It's like it's happening everywhere, and I think it's like, yeah, if there was a million people on the planet, like you wouldn't have to worry about you. It'd be fine. Like you could use pesticides in your area and not think twice about it. Like like yeah, everything's gonna be okay. But we're at 8 billion people. So when 8 billion people do it, like now we got problems. Like because I guess because of the scale of it, and so yeah, it's like you hear these things or you see these things, or at least I do, paying attention to things that are happening in Florida and the Everglades, and then I talk to people like you who are out in Montana, and it's like yeah, we're kind of having a lot of the similar stressors to fisheries. It sounds like.
Totally.
Yeah, I'd say that's definitely right. There's definitely common themes. The nuances change from place to place, but definitely common themes. You're absolutely right.
Yeah, one of the things that is interesting to note from being based in Montana is we're still in one of the most pristine areas in the U.S., right? And our research spans a pretty wide, geographical area, and the situation down, say, in Utah and Colorado is vastly different than what we're seeing up in most of the places in Montana. But that urbanization is creeping northward, right? And so it kind of helps us make predictions about what could happen in the future here if we allow all those people to move in and let the things happen down there that have happened. Try and protect that up here.
Yeah, and we are a new organization, so we've really only been in operation the last couple years, and we're two young guys. But I still think our research has shown some pretty cool stuff. So we started monitoring the Big Hole River last year, and a lot of people are familiar with declines in the upper Missouri Basin, which includes the Big Hole, with these really drastic trout declines over the last 10 or so years, massive crashes in browns and rainbows. And although the populations have bumped up a little bit this year, maybe in response to some recent good water years, still the populations aren't quite what they used to be. And we started doing some bug monitoring last year in combination with this other great organization called the Big Hole River Foundation. And the combination of both of our data sets shows some pretty interesting results where so when we look at where, for example, salmonflies, green drakes, and Mother's Day caddis are most abundant on the Big Hole, and those are three, I would say, the premier hatches on the Big Hole that people really get excited about. What you see is that in the warmest reaches of the river and the reaches with the most amount of dewatering, and the least canopy cover, that's where populations are far, far lowest. So you can get hints of what's going on. We don't have a 30-year data set, on that river, but even after just a couple of years of our data showing where the bugs, how do densities compare in different areas of the river, and how do those correlate with some of the potential stressors, you can definitely see, wow, down in the lower course of the river where it's super warm, they're getting many hoot owl days a year. Temperatures are pushing 70, 75 degrees Fahrenheit sometimes. It's no wonder why there are no salmon flies. And it's crazy because that data is pretty easy to collect, but it didn't exist before.
Right.
So now you have like a stepping stone. And from that, you can build on that research. And the Big Hole River Foundation, that organization I mentioned, their data shows that overall mayflies, stoneflies, and caddisflies are super low in abundance in those same reaches of the river that we showed were warm, dewatered, etc. So just little things like that are important to show, because from data comes action. From data comes also concern and awareness that then brings action. So I think there's so much to do.
Yeah.
That's just one river. Yeah.
Well, what about the, like, is there a, it's, I see this stuff through, and I share stuff, on the Fly Fishing Climate Alliance, which is, sort of climate focused. But, it's like, hey, like, you're going to put stress on fish if water temperatures are, 70 or above, or whatever it is, depending on, I guess, the area. Are there similar temperature gauges with aquatic insects that you're like, hey, when they start hovering around this, like, we need to be focused on whatever it is we need to be focused on to help proliferate the insect life?
Yeah, that's really an interesting question, and kind of not exactly the basis of our graduate research, but that is sort of in the vein of what we studied, is how does temperature broadly affect, the performance of salmon flies specifically. And we did a lot of these really cool experiments where you basically acclimate salmon flies to different temperatures. And then we run this experiment called CT Max, which stands for critical thermal maximum. It's essentially you place them in this chamber and you ramp the temperature up to the point where they no longer can stay on their feet. And that's a response that correlates to, a stress response to high temperature. What we found is they can handle some acute high temperatures that are well above anything you would see in rivers, but that is also not a great representation of what actually happens in these rivers. You don't ever get a spike in temperature that hits 80 degrees for 5 minutes and then goes back down.
Right.
It's slow burn that is what probably is getting them.
Yeah, but a lot of interesting stuff, and for fish, I would say, to answer your question directly, yes, the same stuff occurs with insects as in fish, and the responses can differ from species to species, but there are similar thresholds. Are those thresholds super well known and documented? No, because there's 1,000 more times more species of bugs than fish, and there's less people studying them. But yeah, I mean, as temperatures warm, we're focusing a lot on temperature. Their metabolism increases, and that means they're burning through energy more. And what happens is, for them, it's kind of like a treadmill. If people talk about warm-blooded, cold-blooded just means that your metabolism is just the temperature of the outside environment, right? So as you warm up, it's the same with fish. Their metabolisms are going faster. They need more food. They need more oxygen. But what happens is often you get these thresholds where you get to a threshold where they can't supply that to themselves anymore. There's not enough oxygen in the environment for them to supply it. So they have to be like slowed down and hunkered down. It's almost like being on top of a mountain for them. There's not enough oxygen to sustain them, given their fast, you can call heart rate or whatever. And even when you look at their feeding rates, from cold temperatures, warming, feeding rates start to increase, but then they get to a point where they plateau and then they decline with temperature. So there are all these systems that are kind of adapted to be within this optimal range. And as soon as you push those temperatures subtly, even, especially for a prolonged period outside of that range, you get lower performance. You stop feeding. Summertime is the time where they need to grow, because in the wintertime, they don't grow all that much. And all those problems can just compound. So I would say, I mean, that was a long answer, but yes. But are those thresholds precisely known for your different environmental factors? Unfortunately, not yet. But that's one of our main goals, to do that for the big hatch bugs, for the few dozen species that most people care about. And hopefully in the next years we can start, securing those metrics and informing, hoot owl days, maybe not hoot owl days, but similar conservation strategies via that data.
Yeah, it's interesting. I mean, you got to start somewhere, right? And salmon fly is a prolific fly, and hopefully gain understanding of that and see how it can apply to others. All right, I have a real stupid question to ask. What do aquatic insects eat? This is like, are they is it like so? Because we're talking about systems is what I'm like. All right, well, so the trout are getting active and they need more bugs to like. All right, well, what do the insects eat?
Yeah, there's different types of insects that have different diets. Some insects actually eat other insects; those are predatory insects. A lot of the bigger stoneflies are predatory. Some insects actually scrape algae and detritus off of the rocks. That's probably one of the more common ways is just scavenging and scraping things off of the rocks. Some caddisflies actually weave nets and they'll capture floating debris that comes downstream and eat that. Salmon flies, for instance, they actually chew up mostly like leaf material. They eat that. So they eat a whole range of things, depending on the species.
Interesting.
In and around the rocks, just like the savannah, there's all different species doing different stuff. And
Yeah.
if there's something to be eaten, something's eating it,
Right. All right. So from y'all salmon and fly research, I don't know if we like. I'm not sure how much that encompassed, but were there any other findings that y'all found through your research that were at least interesting enough to continue to pursue or point you in a direction where you're like, hey, I think this could be something that could help from a conservation standpoint?
Well, first, and I want to make sure I'll answer that question in a second, but our graduate school research focuses a ton on salmon flies, as we say, but just for clarity for listeners, the Salmonfly project, we're named the Salmonfly project more as like a namesake. They're an exciting bug. They're a big bug. People get stoked on them. They are in decline. We know that from a bunch of people's research, including ours. But we do research now on many, many different species, pretty much all of them.
Okay.
So we didn't say that in kind of the intro. So I just wanted to be clear about that.
Yeah, totally.
Yeah.
But as far as research that's worth pursuing more, I mean, I'd say all of it. I mean, one of the interesting things that we did recently is we worked with the state of Utah. Every state has what's called a Species Wildlife Action Plan, and they kind of update those on a regular basis every some odd years, I believe every 10 years. And that Species Wildlife Action Plan is basically the state's acknowledgement and strategies for conservation within the state. And for the first time within Utah, aquatic insects or insects in general are being allowed for consideration on their Species Wildlife Action Plan. And if you can show via research that a species is in decline and any likely drivers of that decline, it's designated as a species of greatest conservation need, SGCN. And once it's added to the Species Wildlife Action Plan, a whole bunch of funding opportunities come for doing more research on that bug and conservation projects. So it's pretty exciting working with them because we did a bunch of new analyses from kind of big historical data sets that we were able to mine and showed that salmon flies just since the year 2000 have declined by 84% in the state of Utah.
Out of here.
Yeah, so we knew this from previous work. What I'm going to say next is as far as where have they been lost, the Logan River, that's a blue ribbon trout stream, totally extirpated, locally extinct. The Provo River, another blue ribbon trout stream, most of the river, they've been pushed out. There's a small population in the upper river, up in the national forest, but they're kind of up against their upper elevations kind of threshold. And then there's like some tiny minuscule populations interspersed in the lower and middle river, but they're basically like functionally extinct. There's like, you can work really hard and find like one or two salmon flies. And anyone that knows salmon flies, where they occur, they tend to be super abundant, right? That's what everyone gets so excited about. Declined on the Spanish Fork River, on I'm blanking on the lower Blacksmith Fork, near the Logan River, another great fishery. Anyway, there's a bunch of rivers where they've gotten completely like removed, at least from large portions. And then the data suggests that they've also declined even in areas where they're still hanging on. So super concerning stuff. And it's like those questions that we get most excited about diving into. So historically, like for our grad school research, we did a lot of experimental work to understand the mechanisms by which species or individuals respond to challenges. But now we're trying to get these big trends and then come at it from like a broader ecological perspective through a variety of approaches, big surveys, historical data, GIS, remote sensing, all the tools that we can try and utilize. But it definitely seems like in Utah, it's a human growth problem. Like there's so much more water use because populations are growing like crazy. So dewatering is worse. There's all these trans-basin pipelines moving water from one river to the next. Never mind temperature problems here and there or sedimentation. But it's those big declines that we're most fired up about. So we can hopefully, stop them before they become worse, and then also to catch them early for places like Montana, so they don't follow the same trajectory as places like, portions of Utah that have had massive population growth.
That's crazy at 84%. I mean, it's like, it's throwing the way out, it sounds like, down there. I mean, just kind of looking at it from a decline perspective, that's terrifying.
It is. And I think not to be too doomsday. I mean, like the nice thing about, if there's a nice thing about disturbances like dewatering or sedimentation, by and large, it's around areas of high human use, right? So there in Utah, I would imagine there's going to be for a long, long time populations tucked up in places protected within wilderness or whatever that are going to stay there. But
Right.
it's these populations that are down in like these Salt Lake, Utah County, Cache Valley that have had all these disturbances, this increase in use. That's where it's going to be really an uphill battle,
What is I'm going to ask this, and we're going to sort of get away from the doomsday conversation. But what does healthy aquatic insect habitat, like? What are the ingredients that make a habitat
Healthy.
better for healthy? Yeah.
So, I mean, broadly speaking, less human interference is a good thing. Keeping water in the river is a good thing. They like clean, cold, cool water. Cobbles that are not totally socked up with fine sediments that are caused from, agriculture. That's a plus. Areas, that haven't received massive amounts of pollution from increases in ag or whatever it is that's causing that is all beneficial to insect populations.
Yeah, and the nice thing about ecology is that oftentimes questions like that you just kind of know. A mountainous stream, it's got to look like a mountainous stream. There's got to be vegetation on the side, and the cows don't eat it too much, and it's got to be cool. But if you're in the lowlands and it's a meandering river, it should be silty and a little bit warmer. It's about just keeping things as kind of they naturally should be, and that does take some like fine scale research to know maybe the nitty gritty of what that looks like. But a lot of the time you can just kind of tell, if all sorts of bank erosion and your riffles are getting silty, that's not what a riffle's supposed to look like, man. So yeah, I think James hit on the head there.
Yeah, that makes total right. You just inherently know, like, yes, this is a healthy habitat. There's probably good aquatic life here, therefore good healthy fish population here. Those things it just makes sense. It's kind of common sense, I guess.
There's definitely some sneaky factors though that aren't visible. Like organic pollution, too much fertilizer, runoff from urban areas, cow manure, whatever it is. That ends up being a lot of food for aquatic life like algae. They become hyper abundant. This is kind of sciencey, but at night, all of that algae that didn't used to be there is still breathing oxygen at night. Plants breathe just like you and me. They just produce it too. And in the daytime when the sun's out, and that takes away oxygen at night. So then you can have these big spikes, high oxygen during the day, super low at night. Or, below a mining area, you can have heavy metals, and those are usually invisible. Pesticides, they're definitely invisible, stressors. But, if you just use your mind of saying like, what used to be there, is it still that way? You'll eventually find kind of probably what's healthy versus not.
Interesting. So I'm going to kind of try and draw a picture so that my feeble mind can try and understand this. But basically, we've got aquatic insects that, for the most part, have not been studied too much, right? But there's anecdotal evidence that, hey, I'm starting to see less of these. Whether you're a trout angler or a rancher, I'm not seeing bugs on my windshield. These are things that I'm starting to notice, and through a variety of environmental threats such as too much fertilizer, too much pesticide, too much erosion, maybe climate change is tied to it to some degree, but you basically just have all these things that are happening at the same time that are certainly negatively affecting aquatic insects. Is that, can I at least say that much? It makes sense.
Definitely.
Okay. So we've got aquatic insects in decline. That's bad news for trout and for anglers if you like to fish for some of these species. What is some good news? Aside the fact that the Salmonfly project is on the case, but
that is really good news. No, the good news is, I think what I mentioned earlier is the problem hasn't gotten to the point where we can't fix it yet. We can, in a lot of places, especially across the northern Rockies, there is very healthy fisheries, very healthy bug populations. And with the right protections, we likely can protect those into the future. If everybody plays nicely, we could definitely have a success.
Yeah. Well, one thing that's really inspiring to me, one of our big projects right now is working with the Lolo National Forest. It's a big forest up here in western Montana. And they contracted us to look at their historical bug data, to look at status and trends, and maybe, what factors lead to rising and falling bug populations. And since kind of the opposite of that German study that I mentioned earlier with those massive declines in flying insects, aquatic insects, at least within the Lolo, have gotten more abundant since the year 2000. And the data shows that, in the late 90s, early 2000s, there was some really terrible droughts, really hot years, and it looked like bugs were, had got kind of pushed down from that. And then your more typical climate started to come back. Of course, climate change is still having an effect, but more often than not, climate change is like, it's subtly getting worse over time. And at least within water, in a lot of places, it's not hugely problematic. Yeah, it is problematic. Don't get me wrong. Like, don't come away from the podcast with that understanding. Like, it is a problem, and it's going to get worse if we don't do something about it. But anyway, within this forest, it shows like this increasing trend, and sometimes we get super scared when we see like maybe a 4-year data set with this big decline. Sometimes that can be, normal cycles, and that there can be a bounce back. And within this national forest here, it looks like bug levels, even when they were brought down by temperature or natural, semi-natural drought, they were within like reasonably healthy levels, right? And it's those areas that are worth protecting, you know. And I think public land is so important. I know you have, for the East Coast in your neck of the woods, you have quite a bit of public land. I grew up in Massachusetts and there's like almost none, right?
Okay.
And in Montana, a lot of the West, we have a ton of public land. And those are really amazing places because by and large, they are protected from these massive, um, the massive potential for just like huge habitat destruction, right?
Yep.
There's still like logging here and there, and there's still wildfires that go on here and there. But like by and large, those are protected. And we need to make sure that how our wilderness is managed and protected serves our biodiversity, serves our aquatic insects, serves the natural resources. Because like once in a while there are projects that come in and they kind of try to like revoke some of the protections that were in place. And the integrity of that public land, I think, is so important because that's going to be a huge kind of safe house for a lot of these species, not just bugs, but everything, because they're shielded from, you know, urbanization and ag growth and stuff like that.
Well, I mean, we see here, you know, I mean, Charleston is exploding with population, and there's no, or you know, obviously they're not building it into the ocean, so there's nowhere else to go, right? You're just over time, you're just building, you're just pushing wilderness and wildness further and further and further, and it's like if you don't have these safe havens, like you said, of like pockets or something, like hopefully they're interconnected, but you know, having some way for animals to also coexist with all of this, um, that is, I think, to your point, going to be critical in the future going forward, and maybe aquatic insects are an indicator species because of the work y'all are doing, right? It's like, hey, starting to see this, or it's like, hey, they're really healthy here. We need to focus on the conservation of this area because if they're healthy here, then this could, you know, help the species be more resilient over time. I guess I don't really know that, but just kind of anecdotal on my part.
You're right. I mean, they are an indicator species. You're exactly right. Yep.
Interesting.
As a bio indicator species, like that's classically what people would, you know, collect aquatic insects for, is to measure the water quality. They correlate almost directly with, you know, certain species presence and absence correlates almost directly with water quality.
Interesting. Well, I mean, yeah, it makes sense, right? And aquatic insect wants cleanest water. It's going to do probably, yeah. Okay, that makes sense. All right. So we've talked about these threats. We've talked about Salmonfly project, which are our new heroes of trout fishermen everywhere, or should be. So speaking of fishing, we kind of we've talked on the surface a little bit, but y'all are out in Missoula. How have you been able to get out on the water anytime recently?
Yeah, I try and fish at least once a week. It's kind of it's my favorite thing to do, to be completely frank about it. Yeah, it's been really good. Salmonfly hatch is long gone at this point, but other hatches have been super strong. We're seeing insane numbers of caddis this year. Like I've been out fishing and seeing more caddis than I've seen in many, many years, which is kind of exciting. It's a little bit different. And like tomorrow, I'm going to pack up the truck tonight and head out. I'm going to fish the Moe tomorrow. I'm looking for PMDs, more caddis, and maybe the start of the trico hatch tomorrow will be pretty cool. I think that might be happening. So we'll see.
Yeah.
Yeah.
What so here we go. Now we're like, because you could potentially be a secret weapon on both of y'all could be secret weapons on a fishing trip. How has this understanding of entomology helped your angling ability?
My favorite thing about this is, so we were on the Bitterroot doing some sampling, and there was some guide boats that were watching us do it, and one of them pulled up and was like, hey, what do you guys see? And what should we throw here?
Yeah.
We opened up their fly boxes and we selected a nice, an imitation, a nymph that matched. I think it was an Arctopsyche cat.
Yeah, it's awesome. Like we already had our nets out. We kicked over some rocks, watched the bugs in, and we already knew what was going to be there. But we showed it to him. It was like, look at all these monster green caddis. Like these things are huge. They're everywhere right here. And he's like, okay, all right. He ties on those for his client. But if you're wanting to improve your fishing game, it's pretty easy. If you get some kind of homegrown bug net, flip over some rocks. All you got to do is kick with your feet. Put the net downstream of you, wiggle the rocks under your feet in some place that isn't walked on too much. All those bugs are going to get in there, and at least for nymphing, you're going to see what's most prevalent, and you can tie something like that on, and that's really like I already kind of said, I'm here for the bugs, and that's by far the most important, and fun part of fishing to me are the bugs.
Yeah. Well, I love it. Where is so I saw on your website looks like you'll have some great partners set up, but where can people who are listening to this get more information? Where can they donate? How can they support y'all? How do we get the word out about the Salmonfly project?
Thanks
and
for
support.
Yeah, thanks for asking. So our website, salmonflyproject.org. If you forget that, just put in Salmonfly Project on Google and you'll find us. Donating is super easy if folks are interested in that. It's at the top right hand of the page, and there's a couple options for different ways to donate. Venmo or Square or whatever people want to use. And that's so important. We are a really small organization. We're essentially a 2-person show, and even small amounts go a huge way to helping fund our monitoring projects. We have 12 monitoring projects throughout the Rocky Mountain and Pacific Northwest right now. We're trying to grow and expand more to cover more rivers, a larger region. Hopefully, eventually, we'll be out east. But every little bit counts. We already talked about the stakeholder questionnaire. If folks are local and want to volunteer on a monitoring project, all of our monitoring projects require, and use citizen volunteers to come help us collect bugs. And that's super fun because you're out there with the bugs all day, and we'll teach you all about them, what they are. And so there's lots of different ways people can help, either with time or with donations. And we got, we're on social media and all that kind of stuff. Folks can follow us there if they want to as well.
Cool. Did we cover everything that we should have? I want to make sure that we didn't miss anything.
No, this has been really awesome, Rick. Thank you for having us. This is a great opportunity to, spread our message, and we really appreciate it.
Yeah, no, you asked really great questions. I can't think of a large topic that we didn't cover. But I do want to end with the positivity. I really do think that there's a lot of work that can be done to protect the resources that we enjoy. It's not all doom and gloom. I think there's a lot of areas that we can save and even restore. So we just gotta work at it.
Yeah, and a message to all your angling listeners out there: it's cool again to fish dry flies, right?
Amen. We haven't talked about
Fly on the dry, leave the streamers and the nymphs behind. Go at it.
Dry flies only. I love it. Well, y'all, go ahead.
Oh, sorry, I interrupted you. I was just going to say, we joke around with this logo. We've been thinking about putting it on merch, match the hatch, save the hatch kind of deal.
I'd buy that sticker. Well, first and foremost, thank y'all for what y'all are doing. I think that just talking to people like y'all gives me hope, right? Knowing that there's people out there, but I also, because I interview different people, different organizations, different places, and all this stuff, and it's understanding that it's all interconnected and that all these things collectively make a big impact is really cool. And so hopefully this podcast helps get the word out about what y'all are doing a little bit. I joke around a little bit. I have tens of listeners. That's somewhat true, but so we'll get you out in front of a few people, hopefully a few more than that. But I sincerely appreciate what y'all are doing. I think it's cool, and no one else is doing anything like it. So this is pretty revolutionary. So it's pretty awesome. So thank y'all.
Thanks, Rick. One more thing, if folks want to reach out to us directly, we didn't say our email, but conservation@salmonflyproject.org. You can ask us questions, ask us bug questions, get involved. All of the above. Yeah.
All right. Special thanks to Jackson and James and the Salmonfly Project for everything they are doing to protect what we all love. So if you enjoy the podcast, an absolutely free way to support the show is by leaving it a 5-star rating and review on Apple Podcast or Spotify. It's a chance to tell me what you love about the show, and it helps others discover it too. I'll also mention that there is some The Sustainable Angler merchandise available on the website that have been thoughtfully procured and packaged with zero plastic from a New Earth project, and organic cotton and cotton that is made 100% from dirt to shirt in North Carolina by TS Designs. So you can find that at our website, www.thesustainableangler.com. Thanks for listening, and stay tuned for new episodes dropping every month.